Hi, this is Dr. Shafai, and I'm going to show you using the same time series that we've been working with so far, where we have 3, 4, 5 different 5 past periods, and we have y, or actual values of 450, 495, 518, 563, and 584. And we're trying to, we don't know what the actual is for time period 6, but we'd like to forecast it. I'm going to use the same time series and show you weighted moving average. Now, when you do weighted moving average, we're going to look at different weights placed on past data. So you can have many different models that you generate depending on what weight you want to assign. For the purposes of this demonstration, I'm going to show you a 2-period weighted moving average model where the weights are 3 for the most recent data and 1 for the past data. So if we're going to make forecasts and generate them in this column right here, and we're using a 2-period weighted moving average, I would have to use the 450 and 495. And the average of those will go over here. But it's going to be a weighted average. So the 495 will be given more weight, 3, and the older data will be given the weight of 1. So to make the forecast for time period 3, we get 495 times 3, which is the most recent data, and then we give a weight of 450 times, we give a weight of 1 times 1 to the older data. Now the sum of the weights is 3 plus 1, which is 4, so then we average over the sum of the weights, so we divide by 4. And that answer comes out to be 483.75. So this number is my 2-period weighted moving average forecast for time period 3 when the weights of 3 and 1 are used. Now, once you select those weights, you have to use them consistently throughout. So now, for time period 4, you drop out the 450 and you pick up the new number, the 518. So now this 518 is the most recent data, and the 495 is the older data among the two of them. So for these two now, 518 will be multiplied by 3, and the 495 will be multiplied by 1. But for this problem, the sum of the weights remain to be 4, and so that number gets to be 512.25. Again, you drop the old 495 out, you pick up the new 563, so F5 becomes 563 times 3 plus 518 times 1, divide by 4, and you get that answer to be 551.75. Again, drop the 518 out and pick up the 584. So the forecast for next time period 6, for which we don't know what the actual will be, but we're forecasting it, is 584 times 3 plus 563 times 1, the whole thing divided by 4, and that answer is 578.75. Now, I have forecasts, I have actuals, I can 1, 2, 3 forecasts, 1, 2, 3 actuals related to them. So I can do error analysis for these 3 periods and compute MAD, MSE, MAPE, tracking signal, all of that for this model. You can compare this model to a simple 2-period moving average, or a simple 3-period moving average, or to another 2-period weighted moving average, but your weights could be different. What if for the next model you wanted to use even place heavier weight on the 495 on the recent data, and instead of 3 use 1. I'm sorry, instead of 3 use 5. So you could weigh this 5 and you could weigh this 1 and do another set of calculations, and that way anywhere that you had a 3 you would use a 5. And of course the sum of the weights would have to be is 6, therefore you would have to divide by 6, and that generates a totally whole new set of numbers here. Or you could go through a 3-period weighted moving average, where you could possibly have the weights for a 3-period moving average. Possibly the weights you could assign are, I don't know, let's say 8 and 5 and 2, for instance, or 8, 1, 1, or any combinations such as that. That's the whole point. The whole point is that with these smoothing methods, it's a matter of trial and error to get the best model and the best fit for the time series that you're working with. So it's a matter of trial and error, and there are forecasting software that is out there that actually does that online searching for you. The purpose of this demonstration has been to show you the concept or the framework behind those calculations. And ultimately you do all of this so that then you can do error analysis and you can compare the actuals with the forecasts among various, across various models to see which model is the best fit for that particular time series that you want to forecast. I have prepared videos using POMQM in doing forecasting. I hope you will watch them, and I hope that between this manual work and that video on POMQM and software use, that you will get a good grasp on the material. Thank you very much. This has been Dr. Shafai, and I hope you found this helpful.